Hi everyone, I am Charlie Tan from Sun Yat-sen University. It is my pleasure to share our latest paper at CVPR 2024 titled Siamese Learning with Joint Alignment and Regression for Weakly-Supervised Video Paragraph Grounding. Firstly, I want to talk about the definition of video paragraph grounding (VPG). Given an untrimmed video and a paragraph consisting of multiple sentences, the task of VPG requires to simultaneously localize the temporal interval, i.e., the starting and ending time for each sentence in the video. Currently, fully supervised VPG methods can achieve strong performance, but are suffering from heavy dependence on time-consuming and labor-intensive manual annotations over the entire dataset, i.e., they need to know the accurate temporal boundaries for each sentence to train the model. In this work, we introduce and pioneer to explore the understudied problem of weakly supervised video paragraph grounding (WSVPG), and our goal is to radically eliminate the reliance on temporal annotations. To this end, we propose a novel Siamese learning framework that sufficiently considers the task specificity of VPG in weakly supervised setting. In this work, we have two key observations on VPG. As shown in Figure A, there exists a chronological event sentence alignment, which means the temporal locations of visual events in video are strongly correlated with the relative positions of textual sentences in the paragraph. For example, the middle sentence in the paragraph is more likely to be correlated with content around the temporal midpoint in the video. Also, there exists the pseudo-paragraph boundary supervision. As shown in Figure B, the paragraph description of a video can well represent its global visual information, and a complete paragraph can be used to distinguish the original video content. Concretely, temporarily concatenating the original video with another background video automatically generates the pseudo-boundary labels for paragraph as a query. Motivated by the former observation, we designed the Siamese grounding transformer SiamGTR to tackle WSVPG. The architecture is shown in figure. Specifically, it mainly consists of two way-sharing neighbor branches, i.e., an augmentation branch and an inference branch. The augmentation branch receives a pseudo-video input with synthesized temporal boundaries generated by video concatenation. It regards the entire paragraph as language query to perform end-to-end boundary regression. On the contrary, the inference branch takes as input the normal video stream and then the cross-modal feature alignment under the guidance of temporal order prior between the paragraph sentences and the video content. For model training and inference, the two primary losses for weakly supervised learning are the boundary regression loss and the attention ranking loss, as illustrated below. These two objectives enable the model to jointly learn predicting temporal boundaries and associating relevant cross-modal semantics. During training, we keep the two branches to benefit model from joint alignment and regression supervision, and we only keep the inference branch for inference. Here we give a representative visualization result. In the first and second row, we show the ground truth and the predictions from the baseline model WSTPN. This baseline model only captures the coarse temporal order relationship between sentences. In the third and fourth row, we show the predicted results from our weakly supervised and semi-supervised models. These given boundaries are far more accurate than the baseline, and the semi-supervised model can produce more fine-grained boundary predictions than its weakly supervised counterpart. Finally, the conclusions of our paper are as follows. We are the first to formally introduce the understudied weakly supervised video paragraph grounding WSVPG problem and propose a novel Siamese learning framework which sufficiently considers and utilizes the task specificity of WSVPG. We designed the Siamese grounding transformer SiamGTR for WSVPG. It consists of two way-sharing branches, i.e., an augmentation branch and an inference branch to jointly learn complementary feature alignment and boundary regression supervision without temporal labels. Extensive experimental results verify the effectiveness of our proposed SiamGTR, and our method outperforms the previous state-of-the-art by a large margin in weakly and semi-supervised settings. Thanks for listening.